Have you ever looked up at one of those super skinny skyscrapers and just wondered, how in the world does that not just tip over in the wind? Well, today, we're pulling back the curtain on the hidden science and the secret liquid guardians that keep our tallest buildings standing perfectly still.
Liquid brains. I absolutely love that phrase. It perfectly sets up this amazing mystery, right? Hundreds of feet up in the air, you've got these massive, unseen pools of water. So what's the deal? What are they actually doing up there?
Okay, so to understand the solution, we first have to really get a handle on the problem. And for any tall building, the number one enemy is this invisible, relentless force that just gets stronger and stronger the higher you go. I'm talking, of course, about the wind.
Yeah, down here on the street, you might just feel a nice, gentle breeze. But you go 80 stories up, that same breeze is now a powerful, constant force pushing on the building. Engineers call this wind load, and it is, without a doubt, one of the biggest challenges they face.
And this is where we meet the main villain of our story. See, it's not just the wind's direct push that's the problem. It's this wild phenomenon called vortex shedding. As wind whips around a tower, it creates these swirling pockets of low pressure that literally pull the building from side to side. Let's break it down. As you can see, the wind flows past the building, and these vortices start peeling off, first from one side, then the other. This creates this alternating, rhythmic tug of war, and it's that constant push and pull that makes a skyscraper rock back and forth. Now, a little bit of sway is totally normal for a tall building. It's designed to do that. But if the wind finds just the right rhythm, this gentle dance can turn into something much, much more dangerous. You see, every single tall structure has what's called a natural frequency, a specific rhythm it wants to sway at. The best way to think about it is like a massive slow-motion tuning fork stuck right in the ground. So, here it is, the million-dollar question. What happens when the rhythm of those swirling wind vortices perfectly syncs up with the building's own natural beat? The answer is one word that gives engineers nightmares: resonance. The swaying motions start to amplify each other, building up more and more energy with each sway. This can get so violent that people on the top floors feel sick, and in a worst-case scenario, it could actually threaten the integrity of the whole building. So how on earth do you stop a billion-dollar tower from basically shaking itself apart? Well, the solution isn't about brute strength. It's about some truly elegant physics using something you would never, ever expect. Engineers really have two choices here. They could go the brute force route, just add thousands and thousands of extra tons of expensive steel to try and make the building totally rigid. Or they can outsmart the wind by installing something called a damper, a system designed to soak up all that motion. And that, my friends, brings us to the hero of our story, the tuned liquid damper, better known as the slosh tank. It is, quite literally, a giant tank of water at the top of a skyscraper. It's such a simple, brilliant solution to a massive engineering problem. I know what you're thinking. A giant tub of water? How is that possibly going to stabilize a skyscraper that weighs hundreds of thousands of tons? Well, it all comes down to some beautiful and actually pretty simple physics. The real magic here, the whole trick, is all in the timing. The water is designed to move out of phase with the building. And put simply, that just means when the building sways one way, the water moves the other way. Here's exactly how it works. When the wind pushes the tower to the right, the water's own inertia makes it slosh to the left. The sheer weight of all that sloshing water creates a powerful counterforce, pushing back against the wind and canceling out a huge chunk of the sway. So as that water sloshes back and forth, it's basically soaking up the kinetic energy from the building's movement. It tames the vibrations by turning all that sway energy into the harmless motion of water, long before resonance ever has a chance to build up. So why does all this matter? I mean, why is this such a big deal? Because this surprisingly simple technology unlocks a whole new universe of architectural possibilities. It's the secret sauce that lets us build higher and more daringly than ever before. Seriously, these super skinny skyscrapers you see redefining city skylines, they simply could not exist without dampers. Whether it's a slosh tank or a giant steel pendulum, like the famous one in Taipei 101, these systems are what make those incredible pencil-thin designs possible in the first place. Just take a look at 432 Park Avenue in New York City. It has an unbelievable width-to-height ratio of 1 to 15. That is astonishingly thin, and there's no way, absolutely no way,
It could stay stable against those powerful high-altitude winds without its damping technology. So, what's the bottom line here? Well, these systems do a ton of things for us. They make buildings way safer by cutting down on sway. They make sure the people inside are comfortable. They let architects create these breathtaking new designs. And they end up saving millions of dollars in structural steel. It's a win-win-win-win. And that brings us right back to where we started. The next time you look up at a city skyline, just remember that the most stable, most advanced towers aren't the ones fighting nature. They're the ones working with physics, using the simple power of sloshing water to dance with the wind and stay perfectly balanced. It really makes you wonder, doesn't it? What other ingenious, invisible solutions are quietly at work all around us, shaping the world we live in every single day? That's all for now. Thanks for joining me.